Year 5. How are you? I am here this week to read to you from a book called A Galaxy of Her Own, and it's some amazing stories about women in space. So it's going to sort of deal with the biographies of some very important women who were engineers, journalists, doctors, scientists, mathematicians, physicists, chemists, and how they sort of had an impact on the direction of spaceflight around the world. These were people from Russia, USA, Canada, Japan, South Africa. There's a lady from Iran as well, and of course the UK. And we're sort of going to talk about how these women paved the way, and hopefully they're going to inspire some of you that do have an interest in science or maths or engineering or something like that, and she can show you what you can achieve. So we're going to look at a lady called Mary Jackson, and Mary Jackson was an aerospace engineer. So she worked on the design of the rockets and the space shuttles and stuff like that. And she was born in the USA, 1921, and died in 2005. So this is her biography. So Mary Jackson lived in Virginia, USA, at a time when there was a lot of unjust racial segregation, and white people considered black people to be inferior. Mary spent her life fighting this inequality and helping others to see that they could do so as well. She was very bright and pushed through school and university to get top marks and a degree in maths and physics. She joined NASA's Langley Research Center in 1951 as a computer, where she did mathematical calculations for the engineers. So in 1951, we didn't have computers like we do now. Computers were basically the size of a room, almost essentially, with the technology they had. So a lot of the mathematical calculations that they used were often done by people. And in this case, Mary was one of these experts that had to do these mathematical calculations. So Mary worked in a team that used the supersonic wind tunnel, a machine that blasted models of aeroplanes and spacecraft with air moving nearly at twice the speed of sound, so that engineers could test their designs at high speeds. So we did a little bit of this when we were sort of talking about making our paper aeroplanes, and we were looking at things like resistance, thrust, gravity. So they would have been doing that, but obviously on a much higher level. One day, John Becker, who was a very senior manager, essentially her boss, gave her a calculation. She finished the assignment and handed it in, confident that her work was correct. When Becker questioned the answer, she stood firm. She knew that she had done the sums correctly. Back and forth they went, but Mary was steadfast, so she stood her ground. She knew she'd got the answer right, and she was able to prove it. Eventually, Becker realised that the inputs that he had given her were wrong and the calculations were perfect. He apologised, and word spread that Mary was a force to be reckoned with, unafraid to stand her ground with the top management. Mary's boss at the wind tunnel could see that she was extremely talented. At that time, most universities did not accept women on engineering courses, and black female engineers were unheard of, but he suggested that she take the exams. Mary thought this was a brilliant idea. She had to take some evening classes at the local university to qualify, and because she was black, she needed a special permit to attend. Undaunted, she applied for the permit, got the qualifications, and was promoted, and in 1958 became NASA's first female black engineer. Mary worked in the wind tunnel group for nearly 20 years, producing lots of valuable research and slowly earning her promotions. In fact, she stayed there for so long that her hearing was damaged by the loud noise. Eventually, though, she made a tough decision. She left behind her beloved work in the wind tunnel and took a job at the Federal Women's Program Manager, working tirelessly to improve the lives and careers of all female employees at Langley. She wanted to make sure that there would be many more women to follow in her groundbreaking footsteps. And we've got a picture of Mary here, and it looks like she's looking at sort of blueprints of different designs. She's got a quote from her down here. "We have to do something to get young people interested in science. Sometimes they are not aware of black scientists and don't even know of the career opportunities until it is too late." So I hope this was a first step in sort of showing you that all people of any ethnicity, any gender can work in the space program, and what sort of career opportunities that there are. So this is the book. Maybe you could go have a look at it in your public library or sort of Google it and see if you can find out any of the other stories in there. I'll have a chat to Linden. Maybe we'll do another one next week and we can sort of compare them. There'll be some questions about this up on Seesaw, so you can have a look at that as well. All right? Stay safe. Make sure you get onto this, get your Rockstar done, and all the other things that are going on there as well. All right? Look after yourself, look after your family. We'll see you soon. Bye.
Hi Year 5, so I'm going to read Hidden Figures, and it's very different from what Ben read, which was a biography. Although this is a true story about these 4 very inspirational women, it's written in a very different way. So you can use it for this week's task where we compare this text, Hidden Figures, which is written more like a story, to a biography and think about how they are different. So this is Hidden Figures, the true story of 4 black women and the space race. Dorothy Vaughan, Mary Jackson, Katherine Jackson and Christine Darden were good at math, really good. In 1943, the United States was at war, World War II. Dorothy Vaughan wanted to serve her country by working for the National Advisory Committee for Aeronautics, the government agency that designed aeroplanes. Having the best aeroplanes would help America win the war. Making airplanes fly faster and higher and safer meant doing lots of tests at the agency's Langley Laboratory in Hampton, Virginia. Tests meant numbers, and numbers meant math, and math meant computers. Today we think of computers as machines, but in the 1940s, computers were actual people like Dorothy, Mary, Katherine and Christine. Their job was to do maths. This picture is very important. Have a look at that and have a think about what it makes you feel, what it makes you think, what questions it raises. Because Dorothy was black and a woman, some people thought it would be impossible for her to get a job as a computer. She lived in Virginia, a southern state where laws segregated or kept apart black people and white people. They could not eat in the same restaurants, they could not drink from the same water fountains, they could not use the same restrooms, they could not use the same schools, they could not play the same sports teams, and they could not sit near each other in movie theatres. They could not marry someone of a different race. But Dorothy didn't think it was impossible. She was good at math, really good. She knew she was the right person for the job. She applied, and the laboratory offered her a position as a computer. At work, blacks and whites were kept apart. The white computers worked in one building, and Dorothy and the other black computers worked in a different building in their separate office. Even though they worked on the same kinds of assignments, the black computers and white computers used separate bathrooms and ate in separate lunchrooms. America won the war in 1945, but Dorothy stayed on the job, still trying to make aeroplanes faster and safer. By 1951, the Americans and the Russians were competing to see who could build the best planes. That meant more experiments and more numbers, lots and lots of numbers. And more numbers meant the need for more computers. That's when Mary Jackson got a job as a computer at Langley. She worked in a group that tested model airplanes in wind tunnels. A wind tunnel was a machine like a huge metal box with a powerful fan attached. Mary put model airplanes in the wind tunnel and blasted them with air from the fan. This experiment helped her group improve their designs on the models before building full-size airplanes. Have a look at that picture and what do you notice? Mary wanted to become an engineer, But officials said it was impossible. Most of the engineers at the laboratory were men. And to become an engineer, Mary needed to take high-level maths classes, but she wasn't allowed to go inside the white school where the classes were taught. But Mary was good at math, really good, and she refused to give up. She got permission to enter the school building and take the maths classes, and she earned good grades. Because she didn't give up, Mary Jackson became the first African-American female engineer in the laboratory. Katherine Jackson was good at math and always asked lots of questions. In 1953, she applied to the laboratory for a computer job and was placed on a team that tested actual planes while they were flying in the air. Their research was used to figure out ways to prevent future plane crashes. In one of her first projects, she learned how to analyse turbulence, that's the bumps in the sky, or dangerous gusts of air. No one knew how many lives her work may have helped save. Katherine wanted to help the group prepare its research reports, so she asked if she could go to meetings with the other experts in her team. Her boss told her it was impossible. "Women aren't allowed to attend meetings," he said, but Katherine knew she was as good at maths as everyone else and maybe better. So she asked again, and again, and again. Katherine asked her boss so many times that he finally invited her to the meetings. Katherine was good at math, really good. And because she fought to be treated the same as the men, she became the first woman in her group to sign her name to one of the group's reports. In the 1950s, the Langley Laboratory bought a machine computer that could do math faster than the human computers. At first, these machines made mistakes. Dorothy learned how to program the machines so that they got the right answers. She taught the women in her group how to program their computers too. In 1957, Russia launched a satellite known as Sputnik into orbit around the Earth. The United States started building satellites to explore space too. For years, the laboratory had used math to design airplanes. Now it would need math to create spaceships as well. The government decided to change the agency's name from the National Advisory Committee for Aeronautics to the National Aeronautics and Space Administration, NASA. In 1961, President John F. Kennedy told Congress, "I believe that this nation should commit itself to achieving the goal before the decade is out of landing on the moon and returning him safely to Earth. A man on the moon!" But the first step to getting a man on the moon was to send an astronaut around Earth. NASA was going to need to hire more space experts and more people who were really good at math. Really good. The people at the laboratory had to work together from morning to night to figure out how to send astronaut John Glenn into space and bring him back home to Earth. Katherine Jackson knew she could use math to help. "Tell me where you want his spaceship to land and I'll tell you where to launch it," Katherine told her boss. Katherine helped calculate the trajectories or pathways that rockets travelled through space. She had to plan Glenn's exact route, from takeoff in Florida to splashdown in the Atlantic Ocean. There was no room for error. There she is. No one was better than Katherine at solving these tricky math problems. Days before his mission, John Glenn wanted Katherine to double-check the machine computer's trajectory calculations to make sure it hadn't made any mistakes. When Katherine said the numbers were correct, Glenn was ready to go. On February 20th, 1962, Glenn blasted off into space, circled the Earth and made his way home safely. Meanwhile, laws began to change so that black and white students could go to school together. Blacks fought for the right to sit beside whites on buses and to drink from the same water fountains. At the laboratory, black and white computers started working together in the same offices, eating at the same lunch tables and using the same bathrooms. Black and white moviegoers could sit next to each other in the same theatre. Across the country, people started to think about ways to bring equality to all Americans. Think about how that's relevant to what's happening around the world today. Christine Darden was good at math, and she loved electronic computers. Christine wanted to become an engineer, and thanks to Dorothy, Mary, and Katherine, she knew it was possible. Eventually, she became an engineer for supersonic airplanes, planes flying faster than the speed of sound. But her first job was to help with NASA's mission to the moon. The people at the laboratory prepared for years to send astronauts to the moon, about 238,900 miles away. Finally, on July 20th, 1969, the world watched as the three men arrived on the moon in their Apollo 11 spacecraft. "That's one small step for man, one giant leap for mankind," said astronaut Neil Armstrong when he stepped onto the dusty surface. But it was also a giant leap for Dorothy, Mary, Katherine, Christine, and all of the other computers and engineers who had worked at the laboratory over the years. The moon landing was a success from takeoff to splashdown, but there was no time to rest. Once NASA landed astronauts on the moon, the people at the laboratory began dreaming of sending humans to other planets, such as Mars or Jupiter or Saturn. And they started to imagine hyper-fast space planes that could travel around the Earth at 7 times the speed of sound. The next adventure wouldn't be easy and would require lots of tests and lots more numbers. But Dorothy, Mary, Katherine and Christine knew one thing. With hard work, perseverance and a love of math, anything was possible. And there they are. So the theme in this story is all about perseverance and hard work and not taking no for an answer and being really good at maths. So compare that to last week's theme in Moon Man, whatever you thought the theme, whatever that story was really about, what it's trying to tell us. One of your tasks this week, as well as doing a comparison between that story and the biography, one of your tasks is to think about any questions you have and anything you've learned from these texts, as well as what you like, what you don't like, and any connections that you can make. And you can put that onto a grid and you'll see how to do that in the learning pack.